So if you've gotten this far, then you've probably got yourself a local frognet set up with at least one or two nodes on it, and you may have a an internet tunnel set up with some machines on the other end. Uh, you should be in pretty good shape. The next thing that we want to do is show you how to use the communicator. Now, the communicator was designed and developed as a training tool. I needed to teach people how to use FrogNet memory and what it means to move to this kind of a paradigm in a in an engineering world, uh, and show us how we can gain if we evolve the the architecture from assembly language to C. So the communicator itself is a really nice piece of work, but it's not what I would consider production level. It hasn't been proven in the field. It has ways that I know it can fail. It has some things that hiccup on it that aren't necessarily perfect, but it does the job that I intended it to do, which is teaching you how to use uh, the the FrogNet shared memory system. The communicator does some things a little bit differently because it has shared memory, because it can do things differently. I have done a fair amount of work with streaming systems and videos and audio and things like that, and I have a pretty good idea what it takes to put those things out. I know that with most video systems that are in place today, things like WebRTC, the way that they work is the same way that I handled the problem back in the days when I was doing video games for Sierra Online, which is we use UDP. We use a sequential UDP where we take and put a packet number on it so that on the other end, if we receive a packet in the past, we can throw it away. If we receive it too far in the future, we can hold on to it, whatever, right? Those are the things that you deal with. But what you do on the producer side is you just blast out as much TCP as you can, I'm sorry, UDP as you can. And on the other end, you hope you get it, right? That's an awesome programming model. Um, it works, right? Granted, it works. We were able to do need for speed, uh, high stakes over a modem because we did that. But those of you who ever played the game will have seen more than once an anomaly that happens from that. That anomaly is that you'll be driving along, racing just fine, and then all of a sudden, your opposite car, you know, your opponent will fly in. I mean, literally fly in from somewhere else and appear right in front of you. You know, usually about 100 feet before the finish line. And what that is the uh, the communications catching up, right? We got UDP, we got UDP, we got UDP. Oh, holy cow! There's a really big one here. And the predictor that we'd been running with that said, if you keep doing this, your car is going to go here, 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 was suddenly very, very wrong. And we had to correct that. So having UDP as a transport mechanism works, but it is highly unreliable and extremely problematic. So with the communicator, I took a different approach, right? I stepped back one and said, what am I really trying to do here? What I'm really trying to do is two things. I'm trying to move bytes, video bytes, from a producer to a consumer, and not just one consumer, but multiple consumers. So that implies a certain architecture to me that I need a producer, I need a point in the cloud, a point not necessarily in the cloud, but a point, rendezvous point. That's what I was trying to say. I need a rendezvous point for the various consumers and the producer, which every consumer is also a producer because this is a video call. So I need a rendezvous point for all of these various components coming together. And I must recognize that the transport at the end of that rendezvous point uh, right now is going to be limited by the ability of the transport point, the transit point to support the uh, the protocols and layouts of each individual consumer. We're going to change that with the next one so that we don't have to do it. But right now, the system, when it comes up, will limit the producer to the resolution and frame rate of the slowest consumer, and that's the only problem with it right now that I see from this point of view. Um, I send the so when we're talking about the communicator, what are we talking about? We're talking about something that says, "Hi, I'm me. Here is a phone call I want to make. Here's a phone call I'm maybe in. How do I find a somebody to call? How do I let other people join my call? What happens when the call comes up? What happens when it goes down? All that kind of stuff. That's all control plane, and that's all semantic memory, right? That's frognet memory, and so everything in it is handled through tuple space. What are your receiving parameters, right? What are the constraints that a receiver is going to place on a video link? And we find that, and then we don't have to do anything else, right? All of the producers read that one little, that one piece of data that was stuffed into frognet memory by its producer. The producer has no idea who's going to consume it, but these other guys do, and they automatically adjust, not automatically, but they adjust their transmission to meet what the system can deal with. This is done without sending messages back and forth like crazy. It's done without establishing context through servers or services. It's done strictly through the Frognet memory system. So that just leaves the video stream itself, right, and the audio. I can't send those through Frognet memory because those are memory. I'm sorry, those are streams, and every single frame is new, right? There's no real opportunity for doing any sort of a same diff or anything like that. But what I could do was revisit the decision that all streams must go UDP, because I realized that by setting up a single dedicated server with an open socket back and forth between the producers and the consumers, I'm eliminating what was really the big deal in the old methodologies, right? I'm eliminating the need to build and establish the socket every time I want to send something out, and that's a huge amount of overhead, especially in a TCP land. So by maintaining a permanent socket open, I eliminate that. I eliminate by making it a TCP socket instead of UDP. I eliminate retries. I eliminate scatter shot kind of stuff by making it something that is adaptable to the environment. We make the entire video stream work better, audio too, and the way we receive the data can also be changed. With UDP, you send the entire datagram all at once. That's it. You get one chance. Well, you get one chance every time you send that datagram, and maybe you're going to send it 15 times to receive it once. That's the promise of UDP. What we can do with TCP, because TCP is guaranteed delivery, guaranteed in order. So if we take a video frame, a big video frame, and we break it into smaller segments, and we send that over the dedicated wire, we can reassemble those segments on the other side, construct the frame that we had originally, and pass it on to the AV subsystem while interleaving audio into that same flow. So no longer are we blocked by a large keyframe holding the socket, forever. We send smaller bytes or smaller bits and interleave the higher priority audio, so that what we get is clean, as much as possible, uninterrupted audio, and uh, video that continues working self-adaptively, right? That's a lot of claims, right? That's a big deal, because what I just did was kind of throw out decades of research and development in streaming protocols, but it works. It's the thing I say about everything. I might be wrong, I might be hallucinating, but as far as I can tell, it works. And as long as it works, I'm going to be happy. Prove me wrong. Give me a better way to do it, and we can do it. The system is designed for experiments. It's designed for alternatives, right? Get away from the assembly language model, move to a C, uh, you know, frognet memory kind of model, and and you're in much better shape. Now, this video has gone on for about 12 minutes now, and that's way too long. So I'm going to stop this video, and in the next video, we're going to actually do a demonstration of the communicator. I'm going to show you how to bring it in and how to bring it up, and how to make it work. So I think that now you kind of understand a little more about what went into it, and hopefully you're pretty excited about the kinds of possibilities that Frognet shared memory can bring to you. So we'll see you in the next video. Just hang on.